right? And in turn, the joint chain will be affected. But if you stretch the curve, the joint chain won't stretch. But with this setup that I made here, you could stretch the joint chain as well. So you can have the limb extended, you can have the tail extended as well. Or you could have, if this is the neck or the spine, you can also have the spine extended. Right? So how does it work? What we actually want to do is to scale the joint. So the joint has 3 scale values, right? What we want to scale is to scale the x direction. So if we select all the joints, let's say we select the hierarchy, got all the joints, right? If we scale the x, all the joints will be scaled up. But how much do we scale? That's the question. How much do we scale? How do we determine the scale factor? We determine the scale factor by calculating how much you stretch on the curve. So let me clear this up. And let me explain to you. All right, black. So here's our, wow, that's really ugly. I mean, Microsoft, and okay. All right, so here's our original curve, and our new curve is stretched. Okay, so what we need to figure out is the length of the original curve. Let's call it LO, and the length of the new curve LN, or just new, and this old. Okay, old and new. L represents the length. All right. The old means the undeformed curve, right? It's the original curve. So mathematically, we can do this. This will be the scale factor, right? This is the scale factor. And this will drive the scale x of all the joints, right? So we need to figure out, we need to find a way to get the length of the curve. In Maya, we're going to use something called curve info. The curve info is a node. So we're going to explore how to use the node editor inside Maya. Right, so in Maya, there's something called a node editor. Let's create a new one. Are you familiar with node-based workflow like Unreal Engine, Unity? There are, Unity may not be a node-based, but Unreal Engine is very node-based. Some other software are also very node-based. Node-based, basically a node is a process. So what we're going to do is we are going to, let me just draw some workflow here. So what we need is in the node base we're gonna have curve ORIG, the original curve, which is this guy here, right? And then we have curve, which is this curve here, right? So you're gonna see 2 nodes, and then out of the node we're gonna take the we're going to attach it to something called a curve info. and out of the info we have the length. Out of the info we have a length. I'm going to use this length and going to do some calculation. So this is how the data is flows inside a node-based system. So what we're going to need is this curve here, right? So we're going to bring this curve into the node editor. I'm going to click on this add selected nodes to graph. So here's our curve, and you can see there are two items here. One has the ORIG in the name. That means it's the original curve. This is the deformed version of the curve. So inside this node, we need to extract the length of the curve. To do that, we're going to use the curve info. So you type tab to create, and then, all right, so you need to hit the tab key in order to activate the text box, and then you're going to type curve info, and this is the node that we want. All right, now things are going to get a little tricky and a little technical here. So what we're going to do now is connect these two nodes together. But what are we going to connect? So let's expand this node and see what's available in the output. So there's a bunch of outputs here. What we are interested in is the world space. The world space output contains the information of the CV points and other things. And the curve info node needs an input from the curve. So if we drag the world space out to this white connector here and release it, and we'll click on other, you will find input curve highlighted, meaning that this can be connected to the input curve. So we now have the world space connected to the input curve in the curve info, and then after the curve info node we have the arc length, and this is what we need. The arc length will give us, if we look at the curve info node, it shows us the arc length here, which is 6.3 something, right? And we're going to do the same thing for, could duplicate this and connect the original curve to the curve info node, input curve. All right, so now we have length from the deformed curve and the original curve. We can do a divide between them. So we're going to take output from here, and do a divide. So we're going to do a divide. We're going to use the multiply divide. The multiply divide can either do a multiply or a divide between two inputs. Right, so what is connected to the input one is the deformed curve, right? And the input two would be the original curve. So let's expand this. So the arc length will go into input 1x, and then input 1, 2. Okay, now the result would be the scale factor. So the scale factor is going to scale the joints. So now things are going to be tedious here. So what we need is going to bring in all the joints. It's going to bring in all the joints here. It's going to select all these joints and bring them in here. All right, things are going to be very messy. All right. All right, so if we expand all of them, hit 3 to expand all of them. 1 is to collapse, 2 is to halfway expand, 3 is to expand all the way. Right, so in each joint we have a scale. We want to scale the X only. So the output from here, just the X, will be connected to each of these scale X. All right. Now, if you have like a very long joint chain, you will have to do it one by one. And that's where things are getting tedious. Alright, all done. And now if we grab one of the cluster, now it works. So you can even shrink it, like if you want to shrink it, you can even shrink. So it will get shrink. Alright. But the one thing is that if you stretch it too much, the joints become bigger, and you will start to see the individual. You will start to shape. You start to notice that the bending of the joints, the tube is not deformed smoothly because there's only limited number of joints, and each joint gets scaled up too big, and you start to see the underlying structure of the joints on the mesh. So you can't really stretch it too much.